All right, so let's take a look at a method of solving a system of three variables, and it's very similar to the last method we did. So if you recall, the last method was called Gauss elimination. This one is going to be called Gauss Jordan elimination. So this is section 8.1. And it has to do with matrix solutions. Matrix solutions. So let's go back briefly to Gauss elimination, and we'll make a comparison. And so you can see that it's going to be very much similar to what we did. Okay, so we had three equations, if you recall. Equation 1, 2, and 3. Let's say the first one is 2x minus 5y, 5z, and 17, and then negative x, 3y equals to 4, negative 4 actually, x minus 2y plus 3z, and that'll be a 9. And the process that we used was called Gauss elimination, and I even wrote up here the goal, which was to get a bunch of ones and zeros. So after all the work, and it took exactly 6 steps, this is the result we had. And then this one was y plus 3z, and z equals 2. All right, so the ones and the zeros that I'm referring to are the ones right here, the coefficients. So that was a 1, and then there was zeros below it. This one was a 1, 0 below it, and this one was a 1. All right, and after that process, we had one of the answers automatically. It was from the last part, z. But then we still had the other two that were missing. So x was missing, y was missing, and to get those two, we used a process called back substitution. Well, let's see, let me write it differently. To get those two answers, we use a process called back substitution. Okay, so the new method that I'm going to show you, we don't have to use back substitution anymore. We can just go straight ahead and get the answer right at the very end. Okay, so let's look at the comparison now. And to begin with, we use something called a matrix. And even though it sounds very fancy, all it means is we're just going to write the numbers and forget about the letters. So we call it the augmented matrix. Augmented matrix. So if we just keep the numbers from the previous example, so then it's just going to be 2 minus 5, 5, and wherever you see the equals, we typically write a little bar there. 17, negative 1, 3, 0, negative 4, 1, minus 2, 3, and 9. And then the next thing that is going to be a little bit different is instead of calling them equations, we're going to call them rows. Row 1, row 2, row 3. And as far as the goal, it still involves ones and zeros, but even more this time around. So now it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. And the good thing about this is that once we manage to get all the ones and all the zeros, you're going to be 100% done. This blank is the answer for x. That blank, the answer was for y. That blank, the answer for z. So you don't have to come back and do back substitution. That one is x, y, and z. So no need for back substitution. So you would be done in this case. All right. So then this is going to be our new goal. To get all the ones and all the zeros. The good news is it works exactly the same way. The same method that we used where we were following those three rules where we were doing the ones first and then use the elimination to get the zeros. It works exactly the same way. So let me remind you, they were called, so the rules we were using were called row operations. Well, elementary operations. Let me just call it that way. But instead of saying like number one, I used to say rule number one says you can switch equations. Now we're going to say you can switch rows. Rule number two, multiply or divide by anything you want, just as long as it's not zero. Multiply or divide by non-zero. Rule number three, this is where the elimination part kicks in. You can add equations. Well, add rows, I should say. All right. Next, the pattern that we were looking at. Well, actually, I think this is a good place to list the steps. So instead of the pattern, let's talk about the steps. For Gauss elimination, this guy took a total of 6 steps. For this one, there's going to be a total of, let me see, 9 steps. All right, so let's see what they're going to be. Each one of these is going to be a step. All right, so let's say this is going to be first step right here. Okay, so then let's call this first. Then this is going to be second, third, fourth. Now, in reality, I should say that as long as the 1 is before the zeros, it doesn't matter which 0 you get first. That's what I should say. So right here, we're calling this step number 4. The next step, step number 5, it could be the 0 above or the 0 below. It doesn't really matter which one. So then, for example, if you want to say that's the 5th, then this would be the 6th. But then for the next one, the 1 is first. So that one does have to be 7. And then the zeros, it really doesn't matter which one you do first. So if you wanted to, you could call this 8 and then 9. The important part is the ones are before the zeros. Okay. So the pattern, there's a pattern to knowing how to use the rules. Let's say using the rules. And since we're getting ones and zeros, you always get the ones before the zeros. So get the ones before the zeros. And the next part is that you use the 1 to get the 0. So 1 is your helper. So how do you use the 1? Well, you always, so I guess let me say it this way. When you want to get the 0, multiply the 1 by the opposite. Why the opposite? Because that's how you cancel. All right, so that's the pattern. And then there's 2 more. Since you have to get the ones first, to get the ones, you can use rule number 1 or number 2. In other words, switch or multiply or divide. And to get the zeros, you have to use rule number 3. All right, so I think we're ready. So all of this is essentially the same thing we did with Gauss elimination. So if you understood Gauss elimination, then all of this stuff right here works the same way. It's just going to be, instead of 6 steps, it's going to be 9 steps. All right, so same as Gauss. Alrighty, so let's go ahead and get it started. Okay, so let's see right here. Okay, where did I leave it? So we start with the matrix. So it was 2 minus 5, 5, and then 17. And then it was minus 1, 3, 0, minus 4, 1, minus 2, 3, 9. And going back to the same thing we were doing where we keep things organized by labeling, we used to label equation 1, 2, and 3. Our new labels are going to be row 1, row 2, row 3. All right, so here we go. So what we need is, instead of a 2, this needs to be a 1. That's first. And then after you get the 1, the numbers below need to be zeros, but 1 is first. All right, so here we go. Step number 1. So to get the 1, you can switch equations, or rows, I should say, or multiply or divide. Well, switching is always the easiest option. So if you can see that somebody else has what you need, if somebody else has a 1, then let's just switch it. And I see that row 3 has the 1 that I want. So it looks like we're going to switch. So it's going to be switch row 1 and row 3. All right, so that's going to make it very easy. 1 minus 2, 3, and 9. This is still in the same place. Nothing happened there. And now this is 2 minus 5, 5, and 17. So it looks like I'm off to a good start. Very easy. Next are the zeros. And it doesn't matter which 0 you get first. So I can get this one to be a 0 first. Let's keep things organized. Equation 1, equation 2, equation 3. All right, so it says over here that if you want to get the 0, you need to use row number 3. In other words, you need to add rows. I don't know why I keep writing equations. It's already a habit of mine. I keep saying equations, I mean rows. So I need to add rows. And you're going to use the 1 that you just got first to make the other one zeros. So if that's the case, which 2 rows do you add to get the 0 below? Well, row 1 plus row 2. So let's call that step number 2. So it's going to be row 1 plus row 2 equals your new row 2. Row 1 plus row 2, new row 2. All right, so 1, negative 2, 3, and 9, negative 1, 3, 0, negative 4. If you add them, you get a 0, you get a 1, a 3, and a 5. So that's going to replace the second row. So that means row 1, it stays the same. Row 3 stays the same. The only thing that's different is row 2. So then let's write our answer over here. So row 1 stays the same. 1 minus 2, 3, then a 9. We are switching row 2 with our new answer. And then we didn't do anything with row 3, so that one's still the same. Okay, so progress check. I need a 1 here, then a 0, then a 0. All right, let's look at what I have. I need a 1 here, I have it. I need a 0 here, I have it. So I need a 0 over here, so that's next. But the rule is you need to use the 1 to make the other one into a 0. And we always use the opposite to make it cancel. So then the question is, to row number 1, what do you multiply? So when you add it with row number 3, it's going to cancel. It'll give you 0. Well, the answer is the opposite, which is negative 2. So negative 2. Well, let me be consistent. Use the other color. Negative 2, row 1, plus row 3. That'll be your new row 3. Okay, so here we go, multiply all the way across. So -2. The next one is -2 times -2 is +4. -2 times 3 is -6. -2 times 9 is -18. And then row 3, just bring it over. And then if you add them, that's a 0, exactly like we want it. -1, -1, and -1. All right, so this only affects row number 3. So that's your new row 3, so let's put it there, 0, -1, -1, and then -1. And then the other ones are still the same, just bring them over, 0, 1, 3, 5, 1, -2, 3, and 9. That's your new row 1, row 2, row 3. Progress check. I have a 1, I have a 0, I have a 0. Looks good so far. Okay, let's see what's next. Well, next, it should be the 1 first, then the zeros, and the zeros. It doesn't matter which 0 you get first, as long as it's the one that goes first. So that means that this is supposed to be a 1. And every now and then you get pretty lucky. That's already a 1. I didn't have to do that extra step. So I got lucky right there. So anyways, I forgot to write that this step over here was step number 3. And step number 4, which is getting the 1, is already done for us. There's already a 1 there, so that's done. All right, so what's next? The 0. And let's say if I want to make that one into a 0, I have to get it by adding rows. Which 2 rows? Well, row number 2 and row number 3. You have to use row number 2. You have to. The one inside the red box. And if you add it to row number 3, it cancels already without having to do any extra work. So it's nice that it's just ready to go. And that's step 5. So row 2 plus row 3 is your new row 3. Okay, so 0, 1, 3, 5, 0, -1, -1, -1. That's a 0, that's a 0, that's a 2, and that's a 4. Let's write in our answer. That's your new row 3. So 0, 0, 2, and 4. And then 0, 1, 3, 5, 1, -2, 3, and 9. Progress check. I needed a 1. I got it. I need a 0. I got it. Next is this guy needs to be a 0. Let's label row 1, row 2, row 3. Since we have to use, let me erase this right here. Whoops, I erased too much. Since we have to use this guy to cancel the -2, the pattern was you always use the opposite. In our case, +2. So then, which 2 rows are you going to use? Row number 2 with row number 1, but row number 2 needs a +2. So row 2 times a +2 plus row 1. That's going to be step 6. Okay, so we said 2 times row 2 plus row 1, and that'll give you your new row 1. All right, so if you multiply, 2 times 0 is 0, 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10. Row 1, copy it over, 1, -2, 3, and 9. If you add them, this gives you a 1, 0, 9, and 19. All right, let's put it together again. This is row 1, goes right here, 1, 0, 9, 19. And then row 2 is the same. Row 3 is the same. So we're actually getting close to the end. If you notice, progress check. Now we're over here. Now we need a 1, then the 0, and the 0. Starting off with the 1. So starting off, this guy needs to be a 1. Row 1, row 2, row 3. Now, how do you get the 1s? Well, let's go back to our little pattern over here. It says that to get the 1, you need to use row number 1 or row number 2. In other words, if somebody else has a 1, you can switch. Or, if you don't want to switch, you can multiply or divide. Well, let's keep that in mind. Since we're almost done, I don't think I want to switch anything around. I have everything exactly the way I want it. So switching is not an option. Let's say multiply or divide. To the third row, what can you multiply or divide to turn a 2 into a 1? Well, if you divide any number by itself, doesn't it give you 1? So note, that's the other trick. To get the 1, divide by itself. All right, so that's going to be step number 7. Well, let's make more space. Step number 7 is over here. And we said it was going to be divided by itself. So row 3 divided by 2. That'll give you your new row number 3. All right, so 0 divided by 2, 0 divided by 2, 2 divided by 2, 4 divided by 2. So then that's going to be 0, 0, 1, and 2. That's your new row 3. Zero, 0, 1, and 2. Everything else stays the same. Okay, so far so good. I wanted this one to be a 1, and that it is. Next are the zeros. So it really doesn't matter which one you do first. So I'll pick on that guy. So to turn that guy into a 0, since you have to use the one in the red box, we said the pattern is always use the opposite. So you need a negative 9. Okay, let's label row 1, row 2, row 3. In other words, to row number 3, you're going to multiply a negative 9 and then add it to row number 1. And that'll turn it into a 0. That'll be step 8. All right, so we said negative 9, row 3, plus row 1. That's your new row 1. Okay, so let's multiply. Times the row 3, 0 times negative 9 is 0, times 0, times 1, negative 9, times 2, negative 18. Row 1, bring it over. If you add, you get a 1, then you get a 0, you get a 0, and you get a 1. So if you put everything together, one, 0, 0, and then you get a 1, and then 0, 1, 3, and 5, 0, 0, 1, and 2. Progress check. We're good here. We're good here. Now it's this guy's turn. And you have to use that guy. And we're going to use the opposite. So negative 3. Row 3 plus row 2. That should do the job. So step 9. So if you notice, we're down to the last step because we said it was 9 steps. Opposite on row 3. So negative 3, row 3, plus row 2 is your new row 2. So multiply negative 3 all the way across. That's a 0. That's a 0. Negative 3, negative 6, row 2, 0, 1, 3, and 5. That's a 0. That's a 1. That's a 0. That's a negative 1. Put everything together. 1, 0, 0, 1. And then this is going to be the new answer we just got, 0, 1, 0, negative 1. And finally, 0, 0, 1, 2. So at this point, you're done. So you don't have to do back substitution. The first answer is X. The second answer is Y. The next answer is Z. So then your solution, which is a point of intersection, x, y, and z is the point 1, -1, and 2. All right, so this is called Gauss Jordan elimination. Gauss Jordan elimination. All right, so not to make the video too long, I'll go ahead and stop it right here, and then I'll make a second video with the second part. All right, so practice this one, and then the extra credit I'm going to assign, I'm also going to put that on WebAssign, and it's going to be related to a matrix.